Okay. As a revision, what I will do is I'll take you over the code we have discussed and the concepts we have discussed. So this is the program we started on method overloading. Okay. We started with polymorphism concept. I told you like polymorphism implements in two different ways. One is called compile time polymorphism or static polymorphism. Okay. Or I mean to say the early binding, right? So, and the other one is runtime polymorphism. So we were discussing static polymorphism, which is also called as method overloading. So we created a class called average where we define one method called AVG for finding the average of numbers. So what I did, I named as AVG, which takes two parameters here, int x comma int y. So it takes integer arguments, okay, separated by comma. And then I'm printing integer called to know which method is getting called. I simply calculated the average of two numbers and I'm returning a float here. So converted this into float because we know by default every value will be treated as float. I mean double, sorry. So I have to make it float. Otherwise, you see like we got incompatible type error because the return value was double because overall value we are getting it as double, but the return type as float. So either you change it to double, will not be a problem. Okay, but I just wanted to show you how you can actually tell them don't consider this as a double, consider this as a float so that the whole expression becomes floating point value and then return type matches. So that way you will not be getting error when you're dealing with methods along with return value. Then we created another method which takes three integer arguments. Okay, three integer argument. So we know the rule of method overloading. There are two major rules. One is it should be different in the number of parameters or the type of parameters. So as the type is same, but the number of parameter is different, it's allowed. So name should be same. Okay. The signature of the arguments must be different. That's a rule of method overloading, right? So here the number of parameters are different as we have taken three integer values. Okay, the name is same, AVG. Return type is also same. Return type doesn't matter basically, and along with the access modifier, that doesn't matter as we have already discussed. And I'm printing integer called. Okay. So, and I'm also calculating the average of three integers and then returning it as a floating point value. Then we also implemented a method with double here to show you that the type differs. Even it is of two arguments, it looks same like the first one, but the only thing here is the type is different. So here the type is different. So when I make it as a double, the previous two argument function or two argument method is of type integer. Now this is of type double. So we have taken double x and double y, and I say double called and I calculated the average for double and return type is double because obviously when I'm taking input as double, so expected result will also can be in double. Or if you want still in float, can be written in float, no worries. But as the values are double, so it can be more precise. So I thought let's have the return type as double. So this is all your call. Okay, you can take any return type based on your requirement. Now I just took two parameters of type double. So here the type is different. So it's allowed in method overloading. And accordingly, I'm calculating. Now here, as it says compile time polymorphism. So here the compiler decides based on the values, what you're passing, based on the values, the compiler decides which method we are actually calling. Okay, which method we are actually calling. So here I'm just passing the arguments of type double. So the compiler matches it and see there is a method which takes double as an argument, two values as an argument. Okay. And then it will call this double gets called and accordingly average gets written and I'm printing the average here. Okay. I'm printing the average. Now, when I just get back and compile this program, okay, let's save this and let me see the man prompt. So here the screen. Now, let me compile the code. So when I compile my code as Java C test average dot Java, okay, the test average gets compiled. And now when I run this code, you can see double called and 3.0 as an answer. Okay, so that way there is an exact match. Okay, there is an exact match, and the particular method is getting called as we have three overloaded methods. You see the method with the same name, but either the number of arguments are different or the type of arguments are different. So that way your method is perfectly getting overloaded and there is an exact match. So whenever it finds an exact match, it simply prints it. Similarly, when I call 2 comma 3, do we have an exact match for this? Yes, we have an exact match for this, where we have a method which takes two integer argument, where we have a method which takes two integer argument. So here we are calling an average with two integers, okay? And still there is a method with an exact match. Still there is a method with the exact match. So integer gets called and then the average of integers gets displayed. The average of integer gets displayed. Now let's compile the code and see that which method is getting called. So if you have any questions, please let me know. Okay. Last time we had a lot of questions, but I told like we will be covering up today because still there was some topics to be covered. So now I would like to take up those questions and let's proceed with the next topics. Now you can see here integer called getting displayed and the result is 2.5. The result is 2.5. So this way you can see whenever there is an exact match, whenever there is an exact match, you're calling with two arguments, the two arguments integer gets called. When you're passing two double values, the double gets called. And when you're passing with three integer values, this three integer gets called. Let me show you that as well. So let's say I pass three integers now, 2 comma 3 comma 4. Now if I go here, still there is an exact match. So exact match is getting called and it will display integer called with a value as 3 point. Okay. So this way you can see that the exact match is getting called. But from Java 1.0 itself, there is one more concept called widening, meaning if there is no exact match, Java looks for widening. Let's say you are passing floating point value. You're passing a floating point value. You know, you have seen like whenever I suffix with f, it treated as a floating point value. So whenever you're passing it as a floating point value, then it will look for widening as there is no method for float. If there is no method for float, then what happen? Then it will look for the widening. So float can be converted to double implicitly. That's called widening, right? Converting from smaller type to the bigger type is called widening. So here widening will perform. So that's a second rule that whenever there is no exact match, widening will happen. Okay, whenever there is no exact match, widening will happen. Now you compile the code, run the code as there is no float method. So double gets called. So you can see here DD gets called. But what if I have a method with floating point value, guys? Let's say I create one more method here with float comma float. Okay, with float comma float. Now tell me, what will happen. Even let's make the return type as float and converts into a floating point. Now tell me whether a float method gets called or double method gets called. What do you think? Which method gets called now? Okay, float method gets called or double method gets called, and why? So what changes I did? I'm still calling this with float comma float. So I'm passing two values with float comma float. So earlier we have seen the double is getting called. Now I added a method with float. So which one gets called now? So float gets called. Okay, float gets called. Now I run this code and show you to make things clear that what is the difference between exact match and widening. So when I compile the code, as there is an exact match now, float is getting called. Okay, float is getting called because there is an exact match. So that way, first it will look for the exact match. If it doesn't find the exact match, then it will go for widening. So if there is no float comma float, so there is no exact match, then it goes for widening here, widening. Okay. So this is all from Java 1.0 to 1.4. Now, this is where we started last session. So this is all about the revision for the last session. Now let's go for major changes and new priorities added from Java 5 onward. So let us see what gets added in Java 5. So as I keep telling you that major thing about Java is basically the evaluation, how things getting added in the latest versions of Java. Because I told you Oracle will be releasing the major versions of Java every 6 months. Okay, so that's why upgrading ourselves is the most important thing. And for cracking jobs for big companies, this is very important. Okay, so let's see like how things got added in Java 5. So majorly Java 5, which is also called as J2SE, Java 2 Standard Edition, okay, 5.0, introduced two major features that expanded the overloading resolution rule. One is called auto boxing. Today we will be talking about what is auto boxing, auto unboxing, and the other concept we will be talking about variable length argument. Okay, both are very important. Okay, so let us talk about what is auto boxing and auto unboxing. It will be applicable not only for method overloading, it's one of the very important feature. And also variable length argument is most important feature when it comes to method, because a lot of real-time applications, you will be making use of this variable length argument. So this concept's not only important for method overloading, it is also important for the future concepts as well. Okay, and important concepts for interviews as well. So these new options were assigned specific lower priorities in the resolution hierarchy to avoid breaking the existing code. This is how basically the languages evolved, guys. Because anything added, na, even you may think at the end, like why this, even though these are the best features we got, but still why they got the lower priority. Because whenever new things get added, you cannot simply make them as the highest priority, because the existing codes may break, because a lot of applications may be running with the existing code. The all things will get break if you do that way. So that's why understanding these priorities were very important. So they get the lowest priority, even the concepts are so great. This is how the languages basically evolves, because whenever things gets added, it gives the lowest priority. It keeps the previous things as it is. Okay, so that's we need to understand. Now, first thing is, let's talk about this auto boxing, which got added in Java 5. Widening versus auto boxing priority we will see with Java 5. Auto unboxing we will see, and variable length only. So these are the four things got added in Java 5. Okay. So we'll talk about one by one. We'll talk about what is auto boxing, what is auto boxing versus binding based their priorities, and auto unboxing and variable length argument. So let's get into auto boxing. So what is auto boxing and wrapper classes in overload? So the auto boxing conversion of primitive to its corresponding wrapper class, that is int to integer. This conversion is prioritized below widening. Okay, below widening. So meaning first thing, what is auto boxing? Auto boxing is nothing but converting from the primitive type to wrapper type. Last time I shown you that every primitive type got a wrapper class. Okay, every primitive type got a wrapper class. Just let me show you. I think I have those slides which I have written about the, yeah, here it is. So I told you like for every primitive type, there is a wrapper class. For primitive type like byte, we have a class called byte. For primitive type called short, we have a class called short. For int, we have a class called integer. For long, we have a class called long. For float, we have a class called float. And for double, we have a class called double. And similarly for character. For every type we have, okay, there are 8 primitive data types we have it in Java. Moving forward, we will see those data types as well in depth. Once we complete the characteristics of object-oriented programming, then we'll try to understand the fundamental things what Java provides. Okay, so the flow will be little disturbance, but this is how it should be. Otherwise, we may not able to cover major concepts in a flow. So I'm just going with a flow which basically prefers in industry level and certification level. And we will also be discussing these concepts in depth. Every concept will be discussing as per the industry requirement, as per the placements requirement, as per the uh, certification requirement, and also keeping in mind JNTU will make sure that every concept will be covered in depth. Okay. So anyhow, we're going to talk about these primitive types. Don't worry about it. A lot of questions can be expected from these as well. So we'll be covering it. For now, easy to understand. At least I don't have to, even though we haven't discussed this, but can understand because you come from C background, basically, at least from C background. So understanding the primitive types is not a big deal because you have dealt with primitive types a lot. No doubt, like Java has added few extra data types, okay, additional data types, and there are a lot of differences between C primitive types and Java primitive types, okay, but still it's easy to understand. But I don't want to make you understand in depth for now. Just having an understanding like what primitive types and what are its wrapper classes are enough for now. And we seen like primitives are different and wrappers are different. Let's say, for example, if I go here and change this to capital F, change this to capital F now. So it's a wrapper type. It's a wrapper type. Now look at this and tell me if I call, okay, 2.5 float and 3.5 float, which one gets called now? Which one gets called? Float gets called or double gets called? Is there any exact match? Is there any exact match? Exact match is not there. Okay. Is there any widening possible? Is there any widening possible? Yes. Okay. But why not this type? Because in what I can say in auto boxing, the primitive can be mapped with the uh, wrapper type, right? So I'm passing float as a primitive, no doubt. But in auto boxing, before Java 5, it is not possible. Okay. Uh, but after Java 5, it possible that it can do auto boxing, meaning primitive can be mapped with this type. Okay, this type. Let me show you with an example, a general example as well. What is mean by this auto boxing? Nice. So first it will check for exact match. That's nice, Shruti. Then it will check for. So my question was why auto boxing was not happening? Why it's going for double? Because easily it can map with auto boxing and print float comma float, right? Why it's actually going for double comma double. First, let me show you whether float gets called or double gets called. Okay, so let's first see that. So clear the screen. Now let's compile the code. Okay, let's compile the code and then execute the code. You can see double is getting called. So my question was why double getting called? Why not float? Okay, widening is the second priority. Okay, nice. Okay, widening is a when exact match is not found, it goes for widening. Okay, so even though auto boxing is more preferred, but it follows the priority, right? That's what I told you in the previous slide. Okay, that's what I told you in the slide here that this conversion is prioritized below widening. Okay, below widening it because it goes in the down for the next priority. It's a third priority. That's nice, Shruti. So auto boxing, I hope you got understood what is auto boxing, but let me explain you with another example here, what exactly meant by auto boxing. Basically, before Java 5, okay, let me just comment out these lines and first explains you what exactly happens before Java 5 and what is this auto boxing. It's not only for method overloading, it's a general concept. I'll tell you because we may be using a lot, especially when we go for collections concept. Okay. So I just wanted to tell you a little bit about auto boxing. When we actually go for collections, we may have a very detailed discussion about it, but this concept is useful not only here, it is useful in everywhere actually. So now if I can show you what is auto boxing, let's say for example, when I just make integer x is equal to 10. Okay. So here, like this is how you actually make use of primitive data type. Okay. And here you're creating a variable called x, and a value will be assigned to that variable called 10. How it looks internally? It looks internally like this. A variable is getting created. Okay. A variable gets created here with a variable name as x, having some address, of 4 bytes. Okay. Like in Java, it takes 4 bytes of memory, having a value called 10, So every variable, we know we have these values. Every variable will have this. We'll have a value here. Okay. We'll be having an address. Okay. We'll be having the size of the variable along with the range. And this is my variable name. And it gets created in the stack memory, right? It gets created in this stack. So this is how a variable basically looks alike in Java. When I have to create an object before Java 5, the way we can create an object with a value 10 with wrapper class is like this: integer. Okay, integer. Let's say x is equal to new integer. Okay, x is equal to new integer, and then I can just write 10. So this is how I used to create an integer object before Java 5. Okay, if I have to create an integer object, this is how I need to create an integer object, saying in class is integer. Okay, and this is my object. Along with new operator, I'm calling the constructor where I'm passing the value called 10. It creates me an integer object with a value 10. So here I go, and when I compile, the difference here is an integer object gets created this time. An integer object gets created this time with a value called 10, having an address, but there is no specific size for this. And X is a reference referring to that object. Now, if you look at here, what things you have, this gets first thing is this gets created in heap, and this is my integer object. This is my integer object with value 10 will have its own address as well. And then this is my reference. Okay. So this is the basic difference between a variable and an object. The major difference I can tell you about the variable and an object is, can I do like this so that you can understand the difference between variable and object in a better way? A lot of time you get this question in interviews. Now my question to everyone here is, can I say x is equal to hello? Uh, X is of type integer, incompatible data type. Okay, great. Okay, so here, if you look at here, no, if I can just go here and show you, first of all, let me just compile and show you that it's working. I'll just compile and show you that is it working or not. So when I just go here, compile the code, okay, I'm getting a warning. I'll tell you why. Okay, and then it's working fine. There's nothing wrong. So this is how I used to create an integer object out here. But if I just get back to this, okay, if I get back to this and try to say x is equal to hello, I get an error, right? Why? Because in primitive, that's a basic, I can say this is the major difference you can tell in interviews, difference between a variable and the reference. Variable, once I say that it hold integers, it can hold only integer for its lifetime. Okay, it cannot hold string or any other type. I will be getting error. Okay, I will be getting error. Yeah. So I may get an incompatible type. So let's see that what compiler is talking about. So when I just compile this, I'm getting an error called incompatible type. String cannot be converted to integer. It's not possible to store string in this variable hello, right? So here this x can be become 20, can become 30, can become any value, but it cannot become any other value. It cannot become string. Okay, it cannot become string. So that's the nature of a primitive type. But what if I say x is equal to hello here? What if I say x is equal to hello? Will this works? What do you think, guys? Will this works? Yes or no? Yes. Okay, it will work. That's the meaning of reference. Reference means it says that I'm a reference. Currently, I'm referring to an integer object, but the moment you say x is equal to hello, I may refer to a string object then. X must be of type string then. Okay, but it can refer, right? X can refer to string as well. So that's the meaning of reference. Okay, reference can change, but variables cannot change its value. It's fixed once you declare, but references can be changed. Meaning x can refer to integer object, x can refer to floating point object, x can refer to string object, x can refer to any object. So that is basically the difference between integer and reference. That's what I wanted to make you understand before we do. So here I'm making an object with date primitive type. Okay, but the moment I write like this, okay, integer x is equal to new integer. Okay, integer x is equal to new integer, and then I compile this. It gets compiled, and you see the execution also happens. But you might have seen that there was a warning we are getting actually. Okay, there was a warning we are getting. Let me show you what warning we are getting. It's telling you like this is using some deprecated APIs, meaning I'm using from Java 5 onwards, things got changed. It says no need to do this actually. You can actually simply assign an integer value like 10 to this value like this. Okay, it looks like you're actually using a primitive type. Okay, it's actually looking like a primitive type because you're simply assigning it to 10. You're not using any object. So this is basically called auto boxing. This is basically called as auto boxing. Auto boxing means converting the primitive type to object type automatically. So here you are actually creating an object, but the Java is automatically taking care of it. So this is allowed from Java 5 onwards. Now you see you will not be getting a warning. Let's try compile the code and see whether we are getting a warning or not. We are not getting any warning. Earlier I was getting a warning because from Java 5 onwards, things has been changed. You don't need to use new and then call the constructor for constructing an object. Simply you can assign with a primitive type. Simply you can assign with a primitive type. Clear for all? Did you all understood what is auto boxing? Meantime, I will show you this may not be allowed with the earlier version. Okay, this may not be allowed with the earlier version. Let me just run this with Java 4. Okay, let me run this with Java 4. So I try with different release. Okay, let's try running with Java 4 if it works. Java 1.4 I can say. Okay, Java 1.4, and let's see if it compiles. When I try to do, okay, Java release version is not supported. Okay. Okay, because actually I got a dot class file in Java 9, so it's not working. Let me try with other way. I'll give the source, okay, as I wanted to compile this with 1.4 to show you whether it works with 1.4 or not. Then I'll give a target version because my target is in Java 9, okay. So I'll give a target version. So here, let me give a source as 1.4 and target, okay, as 9. So let's see if it works. Okay. Uh, it says source option is no longer supported. Use 1.6 or later. Okay. So again, I thought of showing you. Somehow it's not allowing me. I thought of showing you like what happens if I compile this in the earlier versions, whether I will get error or not. Okay. I thought of showing you, but it's not accepting for some different reasons here. So let's, but at least you understood like what is auto boxing and how auto boxing supports. So once we're done with the auto boxing, now you can see here that you can actually, if you in if you just say that m of integer a exists, m10 int will call via auto boxing. Now suppose in our example, if there is no double, if there is no double comma double, if there is no double comma double. Now tell me which one gets called now. Let me just put these things. Now suppose I don't have this double comma double. Now tell me which one gets called. Okay, we don't have an exact match, and even widening is not possible. Okay, so we'll go for auto boxing as a third priority. Okay, as a third order. So what actually the compiler look for? The compiler basically look for an exact match. Okay, it will look for an exact match. Let me write it here. First, it will look for an exact match. If exact match is not found, it will look for widening. Okay, it will look for widening. If widening is also not found, then it will go for auto boxing. Then it will go for auto boxing. Clear for all? As Navya says, there is no exact match, there is no widening possible, then only it will go for widening. Whenever if there is an exact match or widening possible, it gets the priority. Auto boxing will get the least priority. Okay, so now you can see here that float gets called. Even though I have taken F capital here, the float gets called. The float gets called. Now I just compile the code and run and show you whether float is getting called or not. So compile the code uh, as test average. Now let's run the code. Okay. And you can see here that float is getting called and we're getting the answer. So this way I can actually do auto boxing. So auto boxing will get the priority whenever there is no exact match, there is no widening possible, then it will go for auto boxing. Then it will go for auto boxing. So I hope with this, all of you get clarity about auto boxing. Let's see if we have a few more questions on this. So the compiler always choose a method that requires only widening over a method that requires auto boxing. This is absolute rule to prevent the ambiguity and maintain type. So here, if you look at this, now, if you have both m long and m integer, calling 10 will choose long widening because it is considered a better match than integer auto boxing. Okay, so it will first go for widening, then it will go for auto boxing. Same like our float and double example. Okay, you can understand widening will get the more priority than the auto boxing. Okay, then unboxing. Unboxing means converting from wrapper type to primitive type is called auto boxing. So similarly, unboxing wrapper to primitive, that is integer to int, is also considered, but it operates within the same hierarchy. So giving integer x is equal to 10 or calling m of int will use unboxing actually. So here we given the value as 10, but we have a primitive type still works because here we will be using auto unboxing. So basically auto boxing means for converting from primitive to wrapper is called auto boxing and reverse is called auto unboxing. So from Java 5 onwards, these two concepts got added. Auto boxing and auto unboxing got added. So whenever you have to convert from primitive to wrapper, we call it as auto boxing. And whenever we are converting from wrapper to primitive, it is called auto unboxing. Okay. So this is all about auto boxing and auto unboxing. Let's go for variable length argument. Okay, let's go for variable length argument. But before this, I wanted to check, is this clear for all? What is auto boxing and auto unboxing? Feature added in Java 5. Do you have any questions? Please let me know. I'll just wait for a minute and then we'll go for the last topic from method overloading and then we'll get into inheritance. But we have few questions to be discussed before we get into inheritance. Possibly if you're all okay, we'll have a small test on method overloading to make sure like everything is clear about method overloading. That will be a good satisfaction for me as well as for you for self-assessment, like how good you are with method overloading as per the requirement of placements and uh, certification. Even though it's simple test, 10 questions, but still it gives a complete idea whether we are all good with all the concepts we have learned so far. Okay, it's just 10 minutes test we'll be having after completing this topic, and then we'll go for the inheritance concept. Now, I wanted to check with everyone, like, is auto boxing and auto unboxing is clear for all? First of all, let's see what is auto boxing with simple example, auto boxing. So we have already seen auto boxing means converting from primitive type to in wrapper type is called auto boxing. So I told you when we say integer x is equal to 10, integer x is equal to 10. Okay, so this is not allowed before Java 5 because here it's a primitive value. It's a literal. Okay, it's a literal, integer literal, I can say. I cannot assign this integer literal to X directly because here we have to create an object. You know the way we have to create an object because I'm using integer class. I'm using integer class here. So you know that in from the beginning you learn anytime you have to create an object in Java, you have to use new and then follow by a constructor. So I shown you this is after Java 5 actually. Okay, this happens from Java 5 onwards. This happens from Java 5. Okay, this happens from Java 5. Whereas before Java 5, we used to do like this integer x is equal to new integer, okay, new integer with a value called 10, right? So here this is before Java 5, okay, before Java 5, but after Java 5 this is allowed because of auto boxing concept. So I hope auto boxing is clear. Okay, auto boxing is clear. What is auto unboxing is reverse. Auto unboxing means converting a wrapper type to primitive type, wrapper type to primitive type. Let's say we have x is equal to 10. Okay. And we have a method called void m, which takes integer value. Okay. Let's take it in y. If take it in y and write a code here now. Now you look here. If I just call this method, if I call this m method with x value. Now tell me what is this value of x now? Which type is this? X is of type is an object or primitive? Looking at this example, you can tell me it's a wrapper type, right? It's a wrapper type. Now show tell wrapper type, and here we have primitive type. Here we have primitive type now. Is it an exact match? Is it an exact match? No, right? Because wrapper is different, primitives is different. Is widening possible? I mean, there is no scope of widening here because if of same type. Now what happens? Converting this wrapper to primitive type, y is of type primitive now, right? Y is of type primitive. So converting from wrapper to primitive is called unboxing. Converting from wrapper to primitive is called unboxing, and converting from primitive to wrapper is called auto boxing. Okay, so this is how the Java will take care of auto boxing and auto unboxing. Okay, thank you for the question, Navya. I hope it helped others as well to understand this auto unboxing concept clearly. But moving forward, we'll be having a very detailed discussion about this concept, especially when we go for collections. We will be having a very detailed discussion about this auto boxing and auto unboxing. We'll use it very frequently in the real-time coding. Okay, it's one of the it's the greatest feature I can say added in Java 5. That's why Java 5 is so popular because Java 5 has a lot of interesting features got added. So among most of the versions, Java 5 is the most popular version. It got a lot of success because of lot of new and interesting features get added. So auto boxing and VARG is among them. So that's why most of the time you may get the questions from Java 5 release. Okay, because a lot of interesting things got added. So we will see one by one when we move forward. Our once we complete the foundational concepts, now once we have the foundational understanding, our major focus will be on the enhancements. Like what things were added in Java 5, Java 6, Java 7, then Java 8, Java 9, Java 11. Okay, so we will see what enhancements got added one by one so that we can cover all the concepts required for your interviews as well as for the certification. Okay. Now, with this note, I wanted to go with the next concept called variable length argument. In short, it is also called as var. By looking at the name, can someone guess like what exactly you think this concept is all about? What do you think, guys? What do you think this var is all about? I hope you might have used, you might have learned. If you know, you can tell me. Otherwise, you can just have a guess and can tell me what is this var is actually meant for. What is it used for? What it does? Argument of same type. Okay. What is mean by variable here? Variable arguments means let's try to understand the name, and let's try to have some guess from the name itself. So what do you think variable arguments? Where arg stands for variable arguments. Very nice, Manoj. It means variable number of arguments. Okay, it means variable number of arguments. Now getting back to our program. Okay, getting back to our program. Now you see, let's say for example, I passes 1 comma 2 comma 3. Do we have any method here which takes 3 integer values in our program? Do we have any method here? It's an important topic, guys. So please listen. I know like you're all active, but I want everyone so that we can easily conclude this and we can have some interesting questions to be discussed followed by a test. So now tell me that do we have a method which takes 1 comma 2 comma 3? Just tell yes or no. Do we have a method in our cohort which takes 1 comma 2 comma 3 as the arguments? No? Okay, let's check. Let's check. Do we have any method? Yes, right? We have a method. Okay. So we have a method here which takes int comma int comma int. So is this exact match? Varshit, you got it now? That it's an exact match? Yes, it's an exact match. So what happens? That integer gets called. Okay. So there is an exact match. So when I just go here, there is an exact match. Okay. So when I compile the code, it gets compiled. And when I run the code, you can see integer getting called, and 2.0 is the average of these numbers. Okay, average of these numbers. So there's an exact match it found. But especially for this program, you know, when you look at for the average, now let's say if I pass 4, 1, 2, 1, comma 2, comma 3, comma 4. Do we have any method for this in our code right now? Do we have any method? Okay. Does exact match possible? Does exact match possible? No. Widening possible? No. Do we have any wrapper type accordingly? No, right? So it will give error. If no match is found, it simply gives you an error telling that nothing is found. Okay. So now let me compile the code. The code compilation gives you error. You see, it's telling you all it's not applicable. This is no suitable method found. Okay, no suitable method found. Int comma int comma int. Okay, because this is not applicable because the number of arguments are different. This is not applicable because the number of arguments are different. This is not applicable. Okay, again the number of arguments are different. This is also not applicable for widening because the number of arguments are different. So all these 4 methods are not applicable. So Java compiler gives you a very detailed error, right? So none of the method is applicable. It's telling you the reason also. Okay. So not only 4, I may pass 5 arguments, I may pass 6 arguments, I may pass 7 arguments to find an average. There's no limit of number of arguments, right? Here it comes variable length argument. So what Java 5 says that I cannot keep adding 4 arguments, 5 arguments, 6 arguments. The code length will become very long, right? You may have 10 arguments, 15 arguments. So which is very difficult to have those many methods just for integer. Imagine again for float, again for double. So it will be very difficult. So what Java says that Java 5 has added something very interesting called variable length argument. It says that I can take the argument of any length. Okay, I can take the argument of any length. If it is 4, if it is 5, even if it is 10, or even if it is 100, I can take. So how to write that code? It's interesting, right? So variable argument allows a method to accept 0 or more arguments. Even 0 argument is acceptable. Even if you don't pass, it works fine. Of specific type, when the compiler checks for overloads, this always gives the lowest priority again. Again, I told you the reason that as even though it's the most latest edition, I mean, it's the best way you can actually implement method overloading, but still it gets the least priority. If the exact match, if widening and auto boxing fails, then only this variable length argument matches. Okay, this is how you can actually provide variable length argument. Okay, you can put this three ellipses. This is called ellipses. So when you keep this three ellipses, it is called variable length argument. Now let's make the method for variable length argument and see if it is working or not. Okay, so I go back to my program and I will just make a method for variable length argument. Okay, variable length argument. Return type is float. Return type is float. I will take a variable of type integer. Okay, put three ellipses and let's take the variable name as x. Variable name as x. Now I will just say that where are called so that you can see variable length argument gets called. Now the logic is also different. Why? Because now here, let me tell you, this variable length argument internally it will be treated as an array. Okay, it will be treated as an array. Okay, before we go for the question, let me show you that it will be treated as an array internally. Okay, you can imagine it gets stored in an array like this. Okay, it gets stored in an array like this. So when I'm passing four values, you can imagine like this. Internally, it will treat as an array, but I'm not passing the array argument, huh? Array as an argument. I'm passing variable length argument. See, passing an array argument is different. Passing the variable length argument is different. Okay, possibly I'll show you with an example. So anyhow, once we deal with arrays. So now you can see here that whatever 1, 2, 3, and 4, whatever I'm passing, it's getting stored in an array with index values like 0, 1, 2, and 3. Okay. So internally it stores like an array, but the way you pass an array, the way you pass the variable length argument is different. But internally it's behaving like an array. So you can actually accordingly you can write your logic. Now I can take a float variable. Okay, let's say float a for average is equal to 0.0. Okay, 0.0 to store the final average. I'll take flow for loop to repeat for int I is equal to 0. I say loop for I less than that x dot length. Okay, x dot length. So it will go till length of the array because I don't know how many arguments I'm passing, right? It goes length of the array, then I plus plus. Inside this for loop, what I do, I'll find the average, or I will just find the sum first of all. Okay, so I'll take one more variable here. Let me just use s only for sum. So I will say s is equal to the previous value of sum plus the current value of array. So this way it will find the sum, and whatever we got this sum for what I have to divide now, guys, if you can tell me at least what should I write below, it means you understood the logic. So please go through with the logic, how I am finding the sum for the array and what should be the value here. I cannot say 2, right? Because I'm not simply finding the average of two numbers. It could be any number. Yeah, very nice. I should say x dot length. Okay. I should say x dot length because here based on the length, I should say like I should divide with that. If it is two numbers, then average of two numbers getting passed. Now tell me if I say 1 comma 2, okay, 1 comma 2, which one gets called now? Variable length arguments get called. Variable length arguments get called. Okay. No. So int gets called, right? Integer gets called because there is an exact match. So remember, even though we have a better solution, this one will get the first priority. Okay. First priority. Now, if I save this, go back and compile the code now. Okay. Now if we compile, it gets compiled. Oh, it's telling possible loss of conversion. You know why it's telling possible loss of conversion? Because by default, it will be treated as double. So we learned that, but we forgot while assigning, it should be assign it as a float, or else you change it to float, whatever. Okay. Now I think this will give you, yeah, This will give you float, so that's okay. So now let's go and compile the code. Okay, let's compile the code. And now let's run the code. And you can see integer is getting called. Okay, because there is an exact match. There is an exact. Now tell me, what if I say just two? What if I say just two? Which method gets called now? Do we have, obviously it doesn't make sense to find an average of a single number, but do we have a method with exact match? Do we have a method with exact match? No. Is widening possible? No. Is auto boxing possible? No. So which one gets called now? Which one gets called now? Variable length argument. Okay, it gets called variable length argument. So when there is no match possible, it will call for variable length argument. Now when I compile, it gets compiled. When I execute, I'm getting the where are called and result is 2.0. Doesn't make sense because average of one number not doesn't make sense. But if I pass 3, 4, 5, 6, any number, you see the average of these many numbers can be found with variable length argument. Now I compile the code gets compiled. Now run the code and you can see where arg is getting called and the average is 4.5. So this feature got added in Java 5, but it gets the least priority in terms of method overloading. So I hope with this, everybody is clear with different ways you can overload the method. Variable length argument means it can take multiple arguments. Okay, it can take multiple arguments. You can see here, I'm passing 1, 2, 3, 4, 5, 6 arguments here now. So I cannot keep making those many methods for accepting these many arguments, right? So in that case, what happened? I will be making a variable length argument. So the syntax for making a variable length argument is I can just keep these 3 dots, which is called ellipses. So if I can keep these 3 dots, Java understands that I'm making a variable length argument now. Now this X can take any arguments, Pranay. It can take 0 argument, it can take 1 argument, it can take 2 argument, 3 argument, 4 argument, 5 arguments, 6, 10, 15, 20, any number of arguments it takes. Now what I'm doing to find the average, first I'm finding the sum. Okay, first finding the sum. So this logic is same for finding the sum of the arrays. Okay, finding the sum of the arrays now. So first I am taking sum is equal to 0.0f. 1 will be added. So it will be like 0.01f. So it will be 1.0. Then second number gets added with the previous value. So it becomes 1.0 plus 2. So gives you 2.0. Okay. And then 3 will be added to this next iteration. So it will be like previous value plus the current value. Okay. The previous value will be current value 5.0. Then a previous value gets added with the current value, which is 4. So that way 4, 5, 6, 7, 8, 9, and 10. Sorry, there was, yeah, this is 3. Okay. So that way this is 6 and 6 getting added with 4.0. So final answer will getting 10 and then we'll divide with the length, which is 4, and I'm getting the answer accordingly. Pranay, you got it? Like how we are finding the logic or finding the sum. Then I'm simply finding the average by dividing the sum value with the length. With 2 numbers, 3 numbers, it's straightforward. But as it is n numbers, I'm writing the logic for finding the sum of the n numbers. So Pranay, is both the concept and the code is clear for you? Like how this variable length argument works? Thank you, Pranay. If we pass double as input, should we create double? Yes, Ajay. Here that is true, but widening, if it is possible, then it will take care, Ajay. But basically, if you have to pass double, then you may have a variable length argument for double. Now you can have only for each type, you can have it, right? If widening is possible, it will take care. Okay. So you don't need to have multiple methods now. You can limit yourself after adding this concept. You can limit yourself to few methods only, Ajay. No need to have multiple methods in your program now. Okay. Great. So now, as a conclusion, let's take up a few questions which has been asked in some big companies. As well, we will be taking one more topic, which is an important interview concept to conclude this topic. Now, look at this example and please tell me the output for this program. Okay. First of all, look at this code. We have variable length argument and we have wrapper type. Okay. Now, if I call this, which one gets called now? What will be the output? Okay. Why integer? Why not variable length argument? Okay. What is the priority here? First priority, second priority, third priority, or fourth priority? Third priority. Okay. So it comes before variable length argument. So that's why integer will be the answer. Okay. Integer will be the answer. Correct. Very nice. Okay. Good. So now you understood with these simple tricky questions as well, right? Now, where are the least specific and therefore the lowest priority, fourth option. They serve as a catch-all and use only when no more specific match is possible. Where are is internally treated as an array actually, right? I also shown you internally how it will be treated as an array. There's a last topic called ambiguity. There was a question last time. Let me tell you what is meant by ambiguity here now. What is meant by ambiguity? If a call method resolves two different methods with an equal number of conversions, I'll explain this with an example now. Okay, I'll explain with an example. Let's go here and make a method. Okay, let's make a method called, let's make this as double, double, double. Okay, double, double, double. So here I will change this to D, D, D called. Okay, D called. Now, if I pass 2 comma 3 comma 4, tell me which one gets called now, which method gets called. Let's see who will answer. As a conclusion, please, I need all of you to have an active participation for the conclusion so that we can go for a test. Okay. So which one gets called? Do we have exact match? No. Okay. We don't have an exact match. So we have integer, integer, we have double, 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 we have float, float, we have double, double, we have vararg. So which one gets called? Exact match is not there. So which rule it will follow, guys? Which rule it will follow? Vararg, auto boxing, widening, exact match, widening. So widening is possible. It will go for widening and it will say that double, double, double called. So clear the screen. Okay. Compile the code. Code gets compiled. And it says incompatible type because I am actually converting into float. Okay, so let's not convert into float because this I'm getting double value. So let's return it as double only. Okay, return this as double only because I'm getting the overall answer as double, then it's trying to convert into float, which is incompatible type. Okay, so let's fix that. Now I will okay, compile the code. This time it will get compiled. Now I will run the code. You can see the code runs and see double, double, double gets called. Even though auto boxing may happen, but it will go for the last priority. So it's go for widening. It's go for widening now. Okay, it go for widening. Now similarly, if I just go here and pass 2.2, 3.5, and then 4.6. Which one gets called, guys? Sorry, I'll make it as float. I'll make it as float. Which one gets called? Come on. which one gets called now? Do we have an exact match? Is widening possible? Do we go for auto boxing? Or we go for VARARG? Sorry, if you are typing, I cannot see your chat. Maybe sometimes it get delays because of the network. Please, if not, please let me know which one gets called. Just type by if you are following me so that I can see if is there any delay in the response. Okay, okay, thank you. So which one gets called now? I'm passing float. Is there any exact match? No. Widening possible? No. Float can be converted to double, right? Widening possible. Okay. So again, the same. Again, the same. So double, double, double gets called. Okay. In from float, it can be converted to double, right? So again, what happens? Double, double, double gets called. Okay. Double, double, double gets called. Now here it's come interesting. So what I will do is I'll add one more method now. I'll add one more method. Look at this carefully. I will just say, okay, float, okay, float double double. So I will just change it to FDD. Now tell me which one gets called now, FDD or DDD? There are two methods where double 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 is there and one float double double is there. Okay, FDD gets called. Why? Because why FDD gets called? Why that gets highest priority? One exact match, two widening, correct? Or it should go for three widening. So obviously it will pick FDD because FDD has one exact match and two widening. So that way it gets more priority. It gets more priority. Now let's look at this, whether FDD is getting called, DDD is getting called. So when I compile and run, you can see FDD is getting called. Clear? So here one widening, two, one exact match, two widening. If I make it as float, 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 float double, okay, I'll make it as FFD. Now, which one gets called? Which one gets called now? FFD, okay? FFD gets called. Only addition, I added more specific, right? I added more specific. So that way, what happens? This way, this will FFD gets called, okay? And then this is getting perfect. Now the confusion starts from here. Let's say I will have one more method. I will have one more method. Float, double, float. Float, double, float. And I'll make it as FDF. Now tell me whether FFD gets called or FDF gets called. Which one gets called? FFD gets called or FDF gets called? So everybody is thinking FFD gets called. Why FFD gets called, guys? Why FFD gets called? Why not FDF? Okay, you mean that two exact match and then widening. Here also two exact match and one widening, right? But the order is there are two exact match in order and then it has to do widening. And here we has to do widening, exact match, widening, exact match. But that's not the way the compiler sees. The compiler sees that there are two methods with two exact match and one widening, correct? How the Java compiler sees that there are two methods with two exact match, one widening. So can you say both are applicable? Order is not important. Okay, this is how we think, but compiler sees in a different way. So don't you think that it gives you an ambiguity because two method is applicable now? Okay, So this is what we called it as ambiguity. So here it will give an error. Order is not important. Here it will say that there are two methods with exact match and two with widening. You see how Java compiler will tell you now. The Java compiler will tell you that reference to average is ambiguous. Okay, both method average float float double and float double float is match. Both are getting match. So that way I will not allow. While if you're not calling this, it's okay. You can have both the methods. But when you are passing the data, whenever there is an ambiguity comes, you may get an error. So this is the most trickiest question you may get in interviews. And we generally think that, okay, if you don't have this knowledge, if we generally think that, and we'll tell that, okay, this is getting called, but the other one is not, but this will give you an ambiguity result. And this is what it's telling you. If a call can be resolved to two different methods with an equal number of conversation steps, then a compiler cannot choose, resulting in an error. Okay, like in this process payment, if we have double euro, okay, and here we have something in a reverse, okay, then it gives an ambiguity result because both can be applicable. Both can be applicable. Correct? Got my point, guys? Is this clear for all? What is this ambiguity problem we will get? Yeah, nice. So with this, we're done with method overloading. I hope now you're all ready for interviews, placements, and certification relevant to method overloading concept. But I strongly recommend please revise, try to solve more questions on this so that you get more clarity about it. Now, quick question on this. Let's see, what do you think will happen now? Which one gets called? Okay, both are possible, correct? And we will get error. Thank you, Sarika. Thank you, Navya. All of you agree with Sarika and Navya that here you may get an error. Okay. So yes, we will be getting a compilation error for this. We'll be getting a compilation error. Why? Because the argument are int it, widening possible for this, even for this widening possible. So both candidates requires are widening. So the compiler cannot decide which one uh, is the most specific match and throw an ambiguous method result. Okay, it will give you ambiguity result. So this way it will give you an. So this is the completion of our method overloading.